Okay. Any questions about the video that we just watched? If not, we'll get started. Can you guys see my screen? Should say alpha beta. Can you guys see my screen? I'll take that as a yes. So last week we completed the mini-max. So today we'll complete the alpha beta and move on to Expectimax. So alpha beta, last week we finished AI move, which is basically we pick the best move for the AI. We try each legal move that is available for us to make or the AI to make, and then we pick the best move by evaluating using the minimax alpha beta function, which we have here, and we didn't implement it yet. And then we return the coordinates that give the highest score, so the coordinate of the tic-tac-toe box. Basically, we set the best score to be equal to negative infinity, and the best move is just a random tuple. And then we loop over each available move using the function that we already have inside week two's tic-tac-toe final. So our tic-tac-toe game, and then we simulate the AI move using the minimax alpha beta function. We undo the simulated move and we return the score that is greatest. So today, let's get started with minimax alpha beta function, which takes in the board, the depth, alpha beta is maximizing, and then the players. Basically, minimax with alpha beta pruning. We call check winner or is draw to see if the game ended. And then if it is maximizing player, then we want to initialize the value to negative infinity since we want to maximize. And we check out each available move again, place the AI player on the move, on the board, and we check alpha beta again using a recursive function. And then we undo the move again, update the alpha and the value, and then check if alpha is greater than beta or equal to beta, which we call a beta cutoff. So we break the loop. Or else, if we're minimizing, then it's the player. And we set the value to positive infinity. Check over each legal move, recurse with is maximizing to true, since we want to, after the human player's turn, then it's the AI's turn, so we want to maximize for the AI's turn. And then we set the value and the beta and check the opposite, where beta is less than or equal to alpha. So now let's get started with, I remember last week I said in the chat, Albert already went, so we'll go with Nicholas, since James said he can't do it. He has to grind socials and science. So, Nicholas, whenever you're free, can you share your screen and we can do alpha beta? And for this one, since we have like nobody here other than you three and James can't do it, we'll just do the whole function. And then like, so do you have any questions before you start?
No.
No. Okay, that's good. Then let's get started with terminal state handling. So it's the top. So we already finished the AI move. you don't need it, and we can just move on to, unless you want to, do you have any questions about AI move?
No.
Or we can move on to the minimax of beta. Let's just move on then. Go up to the top. Yep. So you see line 30, you can put your mouse there. Yep. And then tab. Yep. Good job. Okay, so as the to-do says, we want to call check winner. So do you know how to do that?
No.
Okay. So basically we have a check winner function already, but it's not in this file because it should be in the tic-tac-toe file. But you want to call the function and then set that to a variable. So let's do winner. Can you do winner? Just write it down winner. This is the variable. We want to set it to the value returned by check winner. So let's call check winner. So check winner, you pass in the board.
Hmm?
So the argument or the parameter that gets passed into check winner function is the board.
Yeah.
So let's put that in the parentheses. That's the argument. And basically, check winner returns the player, which is either the AI player or the human player defined on line 12 or 13 that gets passed into the function. Make sense?
Yeah.
Okay. Next, the to do basically says if it is the AI player. So let's do enter if winner is the AI player. You understand this if statement, right? The conditional. Yep. So if winner is the AI player, then we want to return 10 minus the depth. Do you know why it's 10 minus the depth?
Hmm?
Do you know why we set to return 10 minus the depth if the winner is AI player?
Isn't that like because you want to stop? You don't need to continue checking it?
Yeah, that's true, but do you know why we're trying to return that specific value?
No.
So the reason we return it is because we want to stop since there's a winner. But the reason why we set the value that we return to 10 minus the depth, basically that's the score. And we want it to be 10 minus the depth because the faster we have a winner, like, you know what depth is, right? How many iterations we do?
Yeah.
Okay. The shallower it is, the better, because that means the AI player can win faster. Does that make sense? There's
Yes.
less turns that are made before the AI player wins, which is good for that AI player. Does that make sense?
Yeah.
Because the AI player is trying to maximize. Okay, so next we want to do the else because we want to check if the winner is human player. So let's do else if. So L if, yeah, winner equals human player.
Hmm?
Yeah. Then we want to do the opposite, which is depth minus 10. So here we return depth minus 10 because we're trying to minimize. So next we want to also check if it is drawable. We want to check if it's a draw. So
Else or you
set a
left?
very what do you say?
Else or you left?
It
Okay.
should be a if.
Inside D?
No, outside because it's separate from the winner, right? So before that though, we should set the variable. Yeah, after. Yeah. So if you want to choose a random variable that you want to choose, that we set to the value returned by
What's
isDraw.
this variable for?
We want to call isDraw and save that returned value of isDraw to a variable. So you see on line 31, we set the winner to be equal to check winner board. So we want to
Yeah.
kind of do the same thing, but for isDraw. Make sense?
Okay.
Draw equals, yeah. Basically, we want to store that variable. Now we want to check, yep. And then if it is a draw, then we return zero because nobody won. So no one gets points. You can also do if draw
I
because
did draw.
yeah, that could work, but you can also do if draw instead of if draw equals true. Just so you know.
Okay.
Next, number two, you have to go down. Scroll down, yeah. Scroll down to it is yeah, if is maximizing. So line, yeah, pass, yeah. So now we want to initialize the value to negative infinity. You know how to do that? Not using the math library.
No.
Okay. The set value equals negative float.
Float?
Yep. And then it's a function, so parentheses, and inside the parentheses we put string. No, the quotation mark string. Yep. Inf stands for infinity.
Yeah.
This could work, and you can also do the math, but that would mean we have to import the library. But this is easier anyways. We don't even use any other function from the math atoms here, math library. Let me add atom. Okay. Where were we? Yeah, set the value to negative infinity. Now we want to loop over each empty square. So if you want to, yeah, go ahead. So you want to do for the row and column in get available moves. So get available moves basically returns a list of row and column tuples. Make sense? Okay. And we pass in the board. Now we want to, it's a for loop. So what do you end it with? Yep. Enter. Now here, as the to-do says, line 45, we want to place AI player on the board. Yep. So the board's row and C column, we want to put the AI player in that cell. Yep. Enter. Now we want to call the minimax alpha beta function. So, yep, score equals minimax alpha beta. And we pass in the board, the depth, alpha beta, board, the depth. Do you know why it is depth plus one?
No,
Okay. So you do know that we're recursively calling it, right? Do you know what a recursive function is?
I forgot.
Okay. It's a function that calls itself inside of it. Does that much make sense?
Yeah,
Okay. So since it calls itself, we're adding depth plus one because basically we're going down the game tree. So we're doing AI made the move. Now we want to check what happens if the human player makes the move. Then that's one depth higher, right? Does that make sense?
yeah,
Okay. Now we pass in the alpha beta, and then is maximizing, but it's the human player's turn, and the human player is not maximizing. He's minimizing, so it's false. And then we pass in the AI player and the human player. Make sense? Okay. Now we want to undo the simulation. Do you know how to undo it? So, do you understand what I'm referring to when I say undo?
yeah,
Okay. For those that don't know, if you see line 55, we set the board's cell to AI player. Now we want to undo that to what it was before. So, Nicholas, if you can undo it. Yep. We set the board's row and column, that cell to none. Now we want to update the value. You see how the value is negative infinity. We want to see which one's greater, the current score that we got from minimax alpha beta, or that value, which is set to negative infinity. So press enter. So we set value to be the value that is greater between the two score and the value. So the maximum. Because we want to replace value if score is bigger, or keep the value if score is smaller. Make sense?
yeah,
Now we want to update the alpha the same way. Yep. Alpha equals maximum between alpha and the value. And then we want to check if alpha is greater than or equal to beta, because if it is, then we want to break the loop. And this is where we're truncating that game tree and looking at less possible values so that this AI can evaluate faster. And after that, we want to return the value. So go enter. Yeah. Yeah, good job. There we want to return the integer of the value. Yep. We want to do that after the for loop because we want to evaluate each and every one of the possible available moves. Next, we want to do the human side, so the minimizing portion. So it's basically the top, but the opposite. So set the value to positive infinity. Yep. And then we want to loop through each row and column of the tuples returned by get available moves. We set that cell to human player. Oh, you forgot to enter. And then we get the score by calling minimax alpha beta. which is a recursive function. So we're recursively calling it. So one difference here is the true. Since we're minimizing, the next player, which is the AI player, should be maximizing. So we set it to true. Next, we want to set the board to none again, that cell, because we want to undo the simulation. And then now we want to set the value, which since we want to minimize it, we want to take the minimum between value and the score. Same for beta. Now we want to check if beta is less than or equal to alpha. Yep. We want to break, and then we want to return the value. Does this make sense? Any questions here?
Nope.
Okay. So that's it for alpha beta. So you can stop sharing and I'll share my screen. Can you guys see my screen? I'm gonna assume that you guys can see my screen. So here's what you made. Basically, the Minimax alpha beta. So if you guys copy this, whatever you got finished, onto week two's tic-tac-toe and replace the AI move. Oh, I think mine's not this one. So AI move. Last week we did Minimax. So delete that as well. AI move, Minimax, paste, and then we can run it. So here, okay, where's okay? Do you guys have a move that you guys think I should play? Number between 1 and 9. 9, AI chooses the center. Next move, what should I do for the next move? And you guys realized how quick that was, right? Right as soon as we hit enter, it accesses and gives us the solution. The AI's move, 3. The AI chooses 6, 4. AI chooses 1. And we'll just continue with 7. And basically, you either always tie or always lose. You can never win against this AI. You guys can try beating it if you want. Also, actually, let me push this code to GitHub of data. Mm, is- Yep, Minimax alpha beta, Minimax AI. I should actually probably post it in the solution. Here, for Minimax final, and we have Minimax, I mean, alpha beta. Paste this here for you guys. Now you guys should be able to see it. Can you put this code on GitHub? Yes, I'm doing that right now. And I'll share it to you guys, the link. Also, it would be good if you guys can get. Actually, let's try doing it today. Let me first share it to you guys. So here's the two that we did. So it's the Minimax. So that's the folder. Inside the folder, you have the Minimax and the alpha beta. I'll share it to you guys. So I'll share you the link. It's this link. And you guys have the final alpha beta and the Minimax. So at the top, you have all the tic-tac-toe code, and then you'll have the Minimax alpha beta code, and the AI move, and then the game loop. So while you guys are at it, if you guys can all go to my class link. So I shared it in the chat. Can you guys all open that up? When you guys open it up, you guys will see a screen like this. Let me know when you guys have it. And on your laptop, create a folder that you guys want to store your code in. Actually, I think it's best to share your screens. Mm. Nicholas, can you share your screen? So I want to try and get you guys to clone the GitHub page so that you guys can work with GitHub and Git. Unless you guys don't want to though, then we can just head straight to Expectimax. So when you click code, the green button, you'll see HTTPS, and then just on the right side, there'll be a copy and paste logo. Yeah. Now, in your folders or file explorer, just create a folder wherever you want called like code or something, or class or coding class or I can only see your GitHub screen, so let me know when you're done. And then you can open up the terminal. Okay, I can only see your screens.
What do I do? Do
I
I just,
can't see your screen.
which screen can you see?
I can only see the GitHub.
There's the, I'm in the,
Okay. Yeah, you can do it in desktop. Just do right click. Yep. New. Oh, open terminal. Open in terminal.
there's nothing in there.
Yeah, it's good. Uh, can you show the terminal though? Is the terminal open? Yeah, okay. Do git clone, git space clone, space. And I want everyone to follow this as well. Oh, no, no, like git space clone. Yeah, clone, and then space again, and then paste that whatever you copied, and then enter. Oh, you don't have git installed?
I don't think so.
Okay. Okay, then next, after this class, just install git. It'll be really easy. And just run that one command and then you're done. Make sense?
Alright.
Does, okay. Then we can just move on to Expectimax. So next, we'll do Expectimax. Basically, the thought process here is Minimax basically is the AI. We're trying to minimize the human and then maximize the AI. We're just going through each search tree, game tree, and going through all the depth and seeing each possible scenario and seeing who won or lost or drawed. And let me know when you guys are confused about something while I say something. And the alpha beta basically says we don't want to look through each game tree. We want to cut it off when we don't need to search that path. So we can save on time and be more efficient. Expectimax basically is trying to save on time as well, but instead of cutting it off, it's trying to expect what that value would be. So we try and determine like a possible, we're trying to predict what that value will be. Does that make sense? Just continue. So AI move is basically the same. We want to choose the AI's next move using an Expectimax search. So we want to, AI is the maximizing player. We're the minimizing. The opponent is acting uniformly at random. So if you guys don't know what that is, basically the opponent will choose randomly. We're going to assume that. And then the Expectimax will basically take the average score of the opponent's random moves. So we're taking the average of it and setting that to be the value. So that's what our prediction method will be. So same thing here. Best score is negative infinity. Best move is a dummy tuple with some random tuple. We go through every row and column, tuple returned by the get available moves function. We want to simulate the AI move. We set the cell to AI move, AI player, and then we call the Expectimax function. We undo the move, set the cell to none, and then check if the score is greater than best score and update the best score and best move. So Expectimax, the function basically takes in the board that is maximizing and then the players. Basically, we call check winner and is draw again. And then we generate the list of possible moves. And then, like before, if the player is maximizing, set the best to be equal to negative infinity, loop over each row and column, place the AI player on the board, call the expected max function recursively. We undo the move, update the best score. Next, if it is the human player and you're trying to minimize, this is where we're trying to loop over each row and column in the moves, available moves, and then we place the human player on the board, call expected max again, undo the move, return that score. And here is where we're trying to average, since the human player is trying to expect what the AI player is gonna make. So, if there's no questions, we'll head on to you guys sharing your screen. So, Albert already went, Nicholas went, so James can't do it. So, Adam, can you share your screen? Oh, let me share the code as well that you should be working with. So, paste it in the chat whenever you're ready. Open that up, copy and paste that into VS Code or Replit if you use that. Although I do recommend using VS Code now and switching over to VS Code instead of Replit. So whenever you're ready, please share your screen and we'll do the AI move.
Okay.
Yep. So go down to, you'll have to go a bit down. Yeah. Down, 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 down. Yep, right there. Define AI move. Line number 833 around. Yep. Just press enter or something. So like the to-do says, we want to set the best score to negative infinity. Do you know how to do that? Or actually, let's do it in the past, yeah.
Where do I put it? Here.
There, right there. So we set the best score to negative infinity without using the math library. So one thing here, do you know what's wrong with that line?
Um, what?
You're setting it the wrong way. So you're doing equals equals instead of equals. Yep. Does that make sense?
Yeah.
Okay. Next, we want to set the best move to a dummy tuple that you can just do like negative, yeah, -1, -1. Yep. Now we want to iterate over each row and column. You don't need the comment. No, you can just, yeah. So we want to go through each row and column after we call the get available moves function. So get available moves basically returns a list of tuples where the tuple is the row and column, and we pass in the board, enter. We want to simulate the AI move, so we set the cell to AI player. We're basically imagining that this AI player made the move on this cell.
So what do I put?
So you want to set this cell to AI player. Do you know how to set that cell, or do you know what that cell is?
Um,
So we're getting the row and column from get available moves. So you want the board's R row and C column. Yep. The board's R row and C column. That's that one cell. And you want to set that cell to AI player. Does that make sense?
yeah.
Now we want to call score. I mean, Expectimax. So Expectimax is the function that is above this function and it's not implemented yet, but you pass in the board, you pass in 0 for depth because you didn't really start yet, so its depth is just 0. Expectimax, we pass in the board, you pass in the depth, which is 0. You pass in is maximizing, which is false since, yep. And so now you want to undo that move. So do you know which move I'm talking about when I say undo it? It's the line 849. Since we're
So
simulating that the AI player plays there, since it's a simulation, we want to undo it and set it back to what it originally was, which is none. Make sense?
yeah.
Now, what do we want to do next? We want to check
If
if the score is
score.
better. Yeah. So we simulated this AI move. Now we want to check, is this AI move good? Good enough to replace the current one? Yep. If it is better, then we want to replace the score and replace the move. So we replace the score because we want to save it so that if we find a better one, we want to replace it later on. And we save
Yeah.
the best move because if it is the best move, I mean, best score, then we want to return that best move. Make sense?
Yeah, I think we've done this before.
Yeah, it'll feel a bit repetitive, but it's basically three different functions implemented a different way. Does that make sense?
Yeah.
Yep. And then you want to return. Oh, you don't want to return actually. You want to check. Uh, go to that for loop line. The so like subtract, subtract. I mean backspace, backspace. Delete. Yeah, right there. Uh, yeah. There's like weird space, but yeah, you want to do check if the best move is if best move. So one thing why we're doing this is because what if there's a not a best move, like it doesn't get replaced? Then it will error out because negative one is not a uh like valid move. It's not a valid move, right? You can't do negative one in the board. So you want to check if the best move is equal to negative one, then you want to error out. Make sense? So let's try and checking.
Wait,
Yeah.
say it again.
So imagine if we don't find the best move and best move still remains negative one, negative one.
Oh,
We don't want that. So we want to check if at the end of for loop, if it is still -1, -1, we want to raise the error. Yep, we raise it like that, although it wouldn't be a value error. It would be a runtime error. So capital R, yep, that one. And inside the parentheses, we want to say something like AI move called on a full board, or yeah, move not found. Okay, that works too. And then we want to return the best move after the if statement. Because if you put it there, then it will only do it if the best move is -1, -1. Does that make sense?
Yeah.
Okay.
Mhm.
And that's it. So you can stop sharing. Thank you, Adam. Next, we'll implement the Expectimax function. So Albert, if you can share your screen, back to you. Yes. Which one is? Go up. Um, That's the min-max. We want to go to Expectimax. Or you want to just do it on that file? Is that fine with you? Then go down. Actually, okay. Do you want to do this? Do you want to try git cloning? 1 second, let me send you the link. Oh wait, I don't even know if you have Git. Do you have Git installed? Oh, you do. Okay, let me send you the link. Sure, I think so. Okay. You can check. In the terminal. I think you do Git. Oh, you did it. Um, Yeah, you did it. Okay. Yeah, you did it in the weird place, but that's good. It's week 4. Expectimax. Yep. So this one is just the Expectimax. If you want to actually run it, you can just copy and paste that into, but you can just do it here actually for now. Which one's better for you? Where do I run it? Okay. Then just do inside the file, place your pointer on the file, like inside the code. Click on it, Control A, Control C. Oh, I think you have to do it again. Control A, Control C. Go to Solution folder, week 2, 3, I think. Go to week 3. Okay, never mind. Week 4, and then create a file named Expectimax. New file, yeah. Expectimax.py. And then you could do that, or you can do week go to week two of solution. So solution is the bottom one. Week two. No, here, yep. Down there. Yep. No. Yeah, there. CLI final. So the top one. Copy that. Yeah. Although you have to delete the past one. Delete that. No, the whole everything. Okay. And then go up all the way back to line 80. And then we want to copy and paste everything there. Copy that from line 80 to 0. Delete it. Control C, delete. And then go down. Yep. Not all the way down. Go up a bit. You see that AI move? Delete that AI move. The whole define as well. Yep. Yeah, good job. Delete that. And then delete that Expectimax. I mean, above the Expectimax. No, leave that be. Up, 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 up. That one, the Minimax. No, not that one, the one above it. Go up to line 179. Yeah, this one. You want to delete that one. There's more, all the way up. Because it's the whole, yeah, that one as well. Yep, good job. Okay, now we can do it. So expect the max, you want to implement it there. Uh, you have to go down because that's the expect the max function. Yep. No. Go to line 164, tab. Now we can do it. We want to check the winner, so we want to call check winner. Yeah, you can do that. Okay. You want to check if the winner is a player. Okay. And then if it is, then we want to return 10 minus the def. Do you know why we return 10 minus the def? You forgot? Okay. So we return 10 minus the def because the AI player is trying to maximize. And basically, each time we go down that game tree, we want to decrease that score because that just means that we're kind of taking longer time or doing more moves, which is we're trying to when we're trying to maximize it. So we're doing 10 minus the def because each time we go down, we want to kind of subtract from that point. Make sense? So we reward them less. Yeah, okay. So if it's the winner is AI player, then we return 10 minus def. If it's the human player, we want to do the opposite since we're minimizing. So we do def minus 10, and then we check if there's a draw. Yep, return 0 because nobody won. It's a tie. There's no points to anyone. And then we generate the list of possible moves. So go down to line 176. Yep. Here we want to check all the multiple possible moves. And then now we want to check after the if is maximizing. So line 10189. You see that pass, delete that pass. Now we want to initialize best to be negative infinity, not using the library math. Yeah, that's good. Okay, it wrote all the code. Uh, okay, whatever, we can just do it. So we iterate through all the rows and columns of moves, where moves is whatever is returned by get available moves. And basically it returns a list of tuples, and each tuple is a row and column. So we set the board's R row and C column to AI player, and then we simulate what happens if we set that cell to AI player. We call Expectimax the board, and then we set it to none again because we simulated the player, and then we want to just revert it back to what the state it was before. And then we set the best score to be equal to the maximum between best and the current score. Make sense? Okay. Okay. Next. So we initialize the total to be zero. Do you know why we're doing zero instead of positive infinity? Or does anyone know why we're doing total equals zero? Okay, if not. So what's the difference between alpha, beta, and like minimax and what we're trying to do with expectimax here? Does anyone remember? What's like the core quality of expectimax? What does it do differently? So if you guys don't know, expectimax, we're basically trying to predict, right? And how we predict, we're trying to average all of the possible values and we try and guess what the prediction will be. And when doing that prediction, we don't maximize or minimize the human player. We're trying to average it, average the possible values. That's where setting the total to be zero instead of negative infinity or positive infinity. Sounds good? Next, loop over each move. Yep. For each row and column and moves, we set that board cell to be human player. And then we try and check using Expectimax to get a score. We pass in the board def plus one. We set is maximizing to be true. And then we pass in the AI player and the human player. And then we try and undo that move using none because we set the human player. And then we set the total to be add the score, basically. Make sense? Does that make sense, Albert? Yeah? Okay. So here we return at the end. Uh, yeah, right there. Return total divided by length of the moves, or else if there is no moves, then we want to return zero. Do you know why we calculate total, why we return total divided by length of moves, Albert? Do you know why? Do you know what the difference is between the Expectimax and the other functions that we did before? Like, what's the core quality difference? Like, what does Expectimax do differently? It says it in the name, right? We're trying to expect or predict, and that prediction is basically an average of all the total scores. So basically, to take the average, do you guys know what the average is? Do you know? Yeah, that's basically what we did. So we return the total moves, whatever score we added up, and then we divided by all the possible moves that we could make. Or else, if there is no moves, we return zero because, or else it would basically make an error out. Make sense? But yeah, that's basically it for Expectimax. If you go down to AI move, line two, yeah. Go down to 234. This one we already completed, but you can just do tab and yeah, tab it, tab everything, enter, tab it, tab it. So basically although one thing here, after the 242, after that, after that line, like create a line after 232. Oh, Control V, yep, enter, uh, subtract, delete, delete. On that line, do if we want to check if the best move is, yeah, like that says, so tab it. Although it wouldn't be a value error, you want to do runtime error, and it's a capital. Do you guys know why this variable or function is a capital? Do you know what kind of type of or do you guys know what type it is? Have you guys heard of classes? You guys have heard of functions, but have you guys heard of classes? Like just class? No? Okay. Because it's a string. Which one are you talking about? Oh, are you talking about the argument? But you see that runtime error? Yeah, that one. That's basically a class. If you see that doc string, it says class runtime error. Have you guys heard of a class? I'm gonna assume you guys did. But yeah, you can start running it. Can you control save? Yep. And then you see that top right, there'll be a play button, like the YouTube logo kind of. Uh, top right, top right, top right. Yeah, that one. Run Python file. Yeah. Now you can run it. So do like yeah. So what did you choose? Oh, okay, wait. Do it slowly. Control C. Go up arrow, or you can do that. Okay. So choose the number. What did you choose? 5. Okay. For now, just press the number and then we can enter it. So you did 5. Now try another one. 8. So enter it. Good job. Yep. And then we can do something else. What do you want to do? 4. And then AI wins. So this one as well, I think is the AI will always lose or draw, and you can never win against. So either three of these, minimax, expectimax, or alpha beta pruning, you can probably never win. And it also helps that tic-tac-toe is a pretty small game. There's a small amount of possible outcomes, so the AI is really fast. So thank you, and that's it for this week. So next week, let me show you what we'll do. Second, let me share my screen. Hmm. Oh, also, can you guys see my screen? Assuming you guys can. So if you guys see your solution, there'll be something in week 2 called GUI final. That one will basically, you guys saw the terminal one, which is called a CLI, which means command line interface. So this is the command line, and that's the interface. Now, the GUI basically means graphical user interface. So if I run it, you guys can see it here, and you guys will be able to play. This one is, I think it's Minimax. But yeah, you guys will be able to play it using the GUI. It basically uses the same code, but just the difference between the UI, which is tic-tac-toe GUI. Next week, we'll do 2048, where 2048, where we basically play. Have you guys heard of 2048 game? Basically, it's this, and we basically do WASD. I is where we try and get the AI to make a move, and we'll code that up. And basically, we have that to do next week. And let me share the booklet. Can you guys see my screen? I'm gonna assume you guys can. So I will copy the link, share it to you guys so you guys can join. I'll wait for 2 minutes, 1 minute, and I'll stop the recording so that I can upload it.